Lesson 1, Workings of the Web. The topics that we will cover in Lesson 1 are a short history of the Internet, the World Wide Web, introducing HTTP, the HTTP request and response, and HTML forms. Let's begin by reviewing what the World Wide Web is and where it came from. Afterward, we'll take a look at some of the major components that make it work, especially the HTTP protocol used to request and deliver web pages. In the late 1950s, the U.S. government formed the Advanced Research Projects Agency, or ARPA. This was done largely as a response to the Russian success in launching the Sputnik satellite and employed some of the country's top scientific intellects in research work with U.S. military applications. During the 1960s, the agency created a decentralized computer network known as ARPANET. The network linked 4 computers located at the University of California at Los Angeles, Stanford Research Institute, the University of California at Santa Barbara, and the University of Utah, with more nodes added in the early 1970s. The network was designed using the then-new technology of packet switching and was intended as a communication system that would remain functional even if some nodes should be destroyed by a nuclear attack. Email was implemented in 1972, closely followed by the Telnet protocol for logging on to remote computers and the file transfer protocol allowing file transfer between computers. The network continued to develop over time with improvements to its protocols and tools, but it wasn't until 1989 that the now familiar World Wide Web began to take shape. That's when Tim Berners-Lee and his colleagues at the European Particle Physics Laboratory, CERN, proposed the concept of linking documents with hypertext. This was followed in 1993 by the introduction of Mosaic, the first graphical web browser and forerunner of the famous Netscape Navigator. The use of hypertext pages and hyperlinks helped to define the page-based interface model that we still regard as the norm for web applications today. The World Wide Web operates using a client-server networking principle. When you enter the URL or web address of a web page into your browser and click on Go, you ask the browser to make an HTTP request of the particular computer having that address. Once it receives this request, that computer returns the required page to you in a form that your browser can interpret and display. This illustrates this relationship. In the case of the Internet, of course, the server and client computers may be located anywhere in the world. Anyone with even the smallest amount of experience using the World Wide Web will be familiar with the term web page. The traditional user interface for websites involves the visitor navigating among a series of connected pages, each containing text, images, and so forth, much like the pages of a magazine. Basically, each web page is actually a separate file on the server. The collection of individual pages that make up a website is managed by a program called a web server. A web server is a program that interprets HTTP requests and delivers the appropriate web page in a form that your browser can understand. Many examples are available, most running under either Unix/Linux operating systems or under some version of Microsoft Windows. Perhaps the best-known server application is the Apache Web Server from the Apache Software Foundation, an open-source project used to serve millions of websites around the world. Another example is Microsoft's IIS, or Internet Information Services. IIS is often used on host computers running the Microsoft Windows operating system. When we talk about server-side programs, scripts, or languages, we are referring to programs that run on the server computer. Many languages and tools are available for server-side programming, including PHP, Java, and ASP. Sophisticated server setups often also include databases of information that can be addressed by server-side scripts. Though the purposes of these scripts are many and various, they are all basically designed to pre-process a web page before it is returned to you. This means that some or all of the page content will have been modified to fit the context of your request. For example, it might show only those products from a catalog that match your stated hobbies and interests. So, as you can see, server-side scripting allows web pages to be full of rich and varied content, which is way beyond the scope of any design using only static pages. A web browser is a program on a web surfer's computer that is used to interpret and display web pages. The first graphical web browser, Mosaic, eventually developed into the famous range of browsers produced by Netscape. The Netscape series of browsers were once the most successful available, but were eventually joined by Microsoft's Internet Explorer, which subsequently went on to dominate the market. Recent competitive efforts, though, have introduced a wide range of competing browser products, including Opera, Safari, Conqueror, and especially Mozilla's Firefox, an open-source web browser that has recently gained an enthusiastic following. Browsers are readily available for many computer operating systems, including the various versions of Microsoft Windows, Unix, Linux, and Macintosh, as well as for other computing devices ranging from cell phones to PDAs and pocket computers. We already briefly discussed how server scripts can improve your web experience by offering pages that contain rich and varied content created at the server and inserted into the page before it is sent to you. Client-side programming, on the other hand, doesn't happen at the server but right inside the user's web browser after the page has been received. This allows you to carry out many tasks related to the data in the received page, including performing calculations, changing display colors and styles, checking the validity of user input, and much more. Most browsers support some version of a client-side scripting language called JavaScript, which is an integral part of Ajax and is the language we'll be using in this tutorial for client-side programming. Every computer connected to the Internet has a unique numerical address assigned to it called an IP address. However, when you want to view a particular website in your browser, no one wants to have to type in a series of numbers. It's much easier to use the domain name of the site in question. After all, it's much easier to remember www.somedomain.com than something like 198.105.232.4. When you request a web page by its domain name, your Internet service provider submits that domain name to a DNS server. The DNS server then tries to look up the database entry associated with the name and obtain the corresponding IP address. If it's successful, you are connected to the site. Otherwise, you receive an error. The many DNS servers around the Internet are connected together into a network that constantly updates itself as changes are made. When DNS information for a website changes, the revised address information is propagated throughout the DNS servers of the entire Internet, typically within about 24 hours. Various protocols are used for communication over the World Wide Web. Perhaps the most important is HTTP, which is the protocol that is also fundamental to Ajax applications. When you request a web page by typing its address into your web browser, that request is sent using HTTP. The browser is an HTTP client and the web page server is an HTTP server. So basically, HTTP defines a set of rules regarding how messages and other data should be formatted and exchanged between servers and browsers. The HTTP protocol is pretty much like a conversation that is based on a series of questions and answers, which we refer to as HTTP requests and HTTP responses. The contents of HTTP requests and responses are easy to read and understand as they are very close to plain English in their syntax. We will examine the structure of these requests and responses along with a few examples of the sorts of data they may contain. After opening a connection to the intended server, the HTTP client transmits a request in this format: an opening line, optionally a number of header lines, a blank line, optionally a message body. The opening line is usually split into three parts: the name of the method, the path to the required server resource, and the HTTP version being used. A typical opening line might look like this. In this line, we are telling the server that we are sending an HTTP request of the type GET. We are sending this using HTTP version 1.0, and the server resource we require, including its local path, is highlighted here. Header lines are used to send information about the request or about the data being sent in the message body. One parameter and value pair is sent per line, the parameter and value being separated by a colon. Here's an example. For instance, Internet Explorer version 5.5 offers something like this. Another example of a common request header is the accept header. The accept header sorts out what kind of information will be found acceptable as a response from the server. By issuing the header as we did in our previous example, the request is informing the server that the sending application can either accept plain text or HTML responses. The server typically answers a request by using an HTTP response. The first line of the response is called the status line. In that line, the server echoes the HTTP version and gives a response status code, which is a 3-digit integer and a short message known as a reason phrase. Here's an example HTTP response. The response status code and reason phrase are essentially intended as machine and human readable versions of the same message and can sometimes vary a little from server to server. Here we have listed some examples of common status codes and reason phrases. The first digit of the status code usually gives some clue about the nature of the message. The response may also contain header lines, each containing a header and value pair similar to those of the HTTP request, but generally containing information about the server and/or the resource being returned. Web pages often contain fields where you can enter information like select boxes, checkboxes, and fields where you can type information. Table 1.2 lists some popular HTML form tags. After you complete the form, you are usually invited to submit it using an appropriately labeled button or other page element. At this point, the HTML form constructs and sends an HTTP request from the user-entered data. The form, which can use either the GET or POST request type as specified in the method attribute of the form tag. Some say that the main difference between GET and POST requests is that GET requests are just for retrieving data, whereas POST requests can have many uses, such as uploading data, sending mail, and so on. Although there is a hint of truth behind this reasoning, it's helpful to keep in mind the differences between these two HTTP requests in terms of how they're constructed. A GET request encodes the message it sends into a query string, which is appended to the URL of the server resource. A POST request, on the other hand, sends its message in the message body of the request. What actually happens at this point is that the entered data is encoded and sent via an HTTP request to the URL declared in the action attribute of the form, where the submitted data will be processed in some way. Whether the HTTP request is of type GET or POST and the URL to which the form is sent are both determined in the HTML markup of the form. Let's look at the HTML code of a typical form. This snippet of code, when embedded in a web page, produces the simple form shown in here. Let's take a look at the code line by line. First, we begin the form by using the form tag, and in this example we give the tag two attributes. The action attribute determines the URL to which the submitted form will be sent. This may be to another page on the same server and described by a relative path, or to a remote domain, as in the code behind the form in Figure 1.4. Next, we find the attribute method, which determines whether we want the data to be submitted with a GET or a POST request. Now suppose that we completed the form by entering the value Ballard into the surname field. On submitting the form by clicking the Send button, we're taken to this address, where the submitted data will be processed, perhaps adding the surname to a database, for example. The variable surname and its value will also have been sent to this destination page, encoded into the body of the POST request and invisible to users. Now suppose that the first line of the form code looks like this. On using the form, we would still be taken to the same destination, and the same variable and its value would also be transmitted. This time, however, the form would construct and send a GET request containing the data from the form. Looking at the address bar of the browser after successfully submitting the form, we would find that it now contains. Here we can see how the parameter and its value have been appended to the URL. If the form had contained further input fields, the values entered in those fields would also have been appended to the URL as parameter equal value pairs, with each pair separated by an ampersand character. Here's an example in which we assume that the form has a further text input field called first name. Some characters, such as spaces and various punctuation marks, are not allowed to be transmitted in their original form. The HTML form encodes these characters into a form that can be transmitted correctly. An equivalent process decodes these values at the receiving page before processing them, thus making the encoding-decoding operation essentially invisible to the user. We can, however, see what this encoding looks like by making a GET request and examining the URL constructed in doing so. Suppose that instead of the surname field in our form, we have a full name field that asks for the full name of the user and encodes that information into a GET request. Then, after submitting the form, we might see the following URL in the browser. Here the space in the name has been replaced by the plus character. The decoding process at the receiving end removes this character and replaces the space. The XML HTTP request object at the heart of all AJAX applications uses HTTP to make requests of the server and receive responses. The content of these HTTP requests is essentially identical to those generated when an HTML form is submitted. This lesson reviewed the history and architecture of the World Wide Web and covered some basics of server requests and responses using the HTTP protocol. In particular, we discussed how GET and POST requests are constructed and how they are used in HTML forms. Additionally, we saw some examples of responses to these requests that we might receive from the server. You can now test your knowledge in the quiz area, access the scripts we learned in the lab, or go through the lesson again. The choice is yours. Thank you for choosing Sam's Teach Yourself.